Everyone, earlier we had studied about cell adaptation, right? And that was reversible. If it is reversible, it is good, but if it is irreversible, you need to know how to dispose of the car, right? So that is irreversible injury, which we are talking about. In this section we are going to start with necrosis. See, ever since the dawn of civilization, man has always asked one question: what is death? So here we are going to study that. So it's very important, but not about death, but the death of cell. See, what causes it, right? The cause, very mysterious, right? Why does something has to die? See, the mild ischemia which we have studied, that will result in atrophy, right? So that was mild, remember? And the severe type, the severe ischemia, will result in necrosis. How? Let's study the mechanism. See, the severe persistent ischemia will result in severe persistent hypoxia, and that will decrease ATP. Obviously, no oxygen, no ATP. And as we studied earlier, so that is going to inhibit the sodium potassium ATPase, right, in atrophy. So the sodium is increased. Remember, it is increased, right? So sodium is increased and even calcium is increased. Sorry over here, but anyway, right, it's increased. So not only sodium but calcium is also increased over here. So what will we do with calcium? This calcium is this guy, that is a large fat guy, not fat, remember it's fat, that is LFAD, because it is seen as large flocculent amorphous densities in the microscopy. Hence it is called as LFAD. And what this guy will do, he'll call his Appa, not Appa, it's Appa, his father in Tamil, it's Appi. So what is this Appi? Appi is the enzymes which it activates, right? So it has ATPase, P for protease, one more P for phospholipase, and one more E for endonuclease inside the cell. We'll study that, right? So ATPase you already know, right? Because of that, cell swelling and everything is going to happen when these are going to happen, right? Damage. So basically this protease and phospholipase, what is made of phospholipid bilayer? That is plasma membrane, right? So plasma membrane of the cell and the lysosomes membrane is broken. Oh my god, now we have unleashed the devil inside, that is the lysosome. Lysosome, as you know, it's already called a suicide sac, right? So it is going to commit suicide. So it is going to release all the right enzymes that will result in the tissue damage. And also because of the tissue damage, they are going to give a call to this guy, right? Who is this guy? That is WBC army. They will call the WBC army, and this neutrophilic inflammation, and hence there will be acute inflammation in necrosis. Remember, there is always an inflammation in necrosis. So those guys will come and kill the cell itself. So that is how the death happens. That is the necrosis, right? The secret is exposed. Also, we have the endonuclease, right? So as the name nucleus is there, right? So it affects the nucleus. So see what all it can do. It can result in pycnosis, right? That is, the nucleus is becoming very small. That is a pycnosis, and it will get broken down or fragmented. That is called as karyopyxis, right? Karyopyxis, that is the fragmentation of the nucleus can happen, and next it can be completely dissolved, right? That is the dissolution, that is karyolysis. So this is the steps: pycnosis, after that we have karyopyxis, and next karyolysis. Remember, this also happens in necrosis, right? So in light microscopy, how you can see that? Because of all the fragmented proteins they stain pink, right? That is called as eosinophil. Actually, it doesn't mean that the eosinophils are increased over here. Eosinophilia means the pink color is increased, right? So there is increased eosinophilia, and since the nucleus, they are broken down, they are right basophilic, right? And these are decreased, that is decreased basophilia, in the sense the color, the blue, is going to get decreased. And in electron microscopy, for necrosis, we see something called as the myelin figures, right? So that is how it appears. That is the circly thing. That is the myelin figures will be seen in the electron microscope. So coming to the types of necrosis, mainly there are only two types, right? But there are various, we'll study that. Mainly it is coagulative and liquefactive. Liquid, it's like liquid, right? Coagulative, coagulation, solid. Remember, it's solid, right? And we need to know that. And this coagulative is the most common type, right? Solid is the most common type, right? Everything you want to be solid, you don't want to be liquid, right? Obviously your pen, your books, everything should be solid. So this is the most common type. And the appearance, it appears like right, what is this? Rest in peace. Yeah, that is a tombstone which I am telling, right? It appears like a tombstone appearance, and there's a moth above. So remember, it is also called as moth-eaten appearance, and glass particle. So remember, there is glassy appearance. So all these three are seen in coagulative necrosis. But remember, right? The cell membrane is intact over here, right? As you can see, the cell membrane is intact over here. Even the whatever broken down is happening, the cell membrane is intact. That is coagulative necrosis. An example, since I told you it is solid, right? So what all are solid? Most of the organs, right? So ischemia to all the solid organs except you want your brain to be like liquid, right? Water. I am liquid. That's what the brain is telling over here. So that is liquefactive necrosis occurs in the brain, right? Neuroplasticity. You don't want it to be solid, right? So remember, ischemia to all the solid organs except the brain. And what is the solid most organ which you can think, right? That is muscles, right? Muscles, they are very solid and you need to be very solid, right? You need to be very strong and everything. So remember, this muscle, that is what your abdominal muscles, that can undergo degeneration, and that is coagulative necrosis, which can happen in typhoid, right? When typhoid comes, you lose your six pack. So sad, right? So better not get a typhoid if you want to build a body. And this is called as Zenker's degeneration. Remember, Zenker was a bodybuilder, just for remembering sake, and he developed this degeneration. Then he got very angry, hence fire. So remember, thermal. From that, remember thermal, right? So thermal injuries will also result in the coagulative necrosis. And the gangrene, obviously we have the dry gangrene over here. Solids, they are dry, right? If there is wet, it should be liquid, right? So that is for the coagulative necrosis. We'll see the histology later. And coming to the liquefactive necrosis. In the liquefactive necrosis, everything is liquid, right? All the cells are becoming liquid. That is nothing but your famous yellow thing, disgusting, but anyway, that is pus. That is the liquefactive necrosis. And it is made of the necrosis. Along with that is the WBCs, which they call, right? The white cells to kill everyone. That is the WBCs, and the necrosis together form the pus. And the example, as we studied earlier, brain is liquid, right? So there is ischemia to CNS and wet gangrene. And also coagulative necrosis, all the difference is there in the management of the cell membrane, right? And when the bacteria is going to get attached to the coagulative necrosis, that can be converted into liquefactive necrosis. Next, so these are the two main types, right? That is the coagulative and liquefactory. Other types, that is mainly caseous necrosis. Caseous necrosis is nothing, but actually it is more coagulative than liquefactive. It can be liquefactive, but it is more of a coagulative type. And this mainly happens lungs, right? So it happens in the lungs. Remember, caseous, right? Caseous lungs were affected. So caseous lungs. So lungs, the famous disease of a lung, which is TB, that you will remember, right? And remember, TB program is Nixche, right? And CM was typing that in his HP laptop. From that, remember CM and HP. I mean, just remember these three, that is a TB, CM and HP. CM is coccidiomeiosis and HP is histoplasmosis. So all these are the types of caseous necrosis, and that mainly happens in the lung, right? And coming to the fatty necrosis, so this diagram, funny diagram, fat guy, he's drinking a lot of alcohol and injuring his pancreas, right? And obviously he is drinking, so he'll fall down. So from that, remember two examples of fatty necrosis, that is acute pancreatitis and trauma. Next we have fibrinoid necrosis. So what is this fibrinoid necrosis? Fibrinoid necrosis in the sense that what is this red color thing? Fibrin, right? Fibrin threads. This is nothing but your blood vessels. And what happens in that? See, if there's a constant, there should be a constant irritation, right? That's what we have studied. That's how the necrosis happens. So constant irritation is because of the hypertension, which is pressurizing the blood vessel. So that is because of malignant hypertension. And this guy, white guy, what is he doing here? That is mainly immune complex deposition in the blood vessels. And next we have the vasculitis, right? So that will result in inflammation. So hence the vasculitis, all this will make something called as a fibrinoid necrosis. So let's see this histology. What is this? You may think this is coagulative necrosis, liquefactive necrosis, but no. This is for the revision sake, which I have put it over here. This is the histology of the atropic, like hydropic change, which you have studied in the atropy, right? For the cellular adaptation in the earlier chapter. So this is the hydropic change. What happens in the hydropic change we have studied, right? I mean, the cell is going to become big and there's chromatin condensation and fat globules and everything. We have studied this earlier in the cell adaptation chapter. So this is the histology of that. Next, these are the images of coagulative necrosis. See, coagulative necrosis, as I told you, the cell membrane should be preserved. So as you can see here, I know it's not that clear, but still the cell membranes are clear and you cannot see the nucleus. So this is coagulative necrosis, which you can see over here. And the liquefactive necrosis, you will see nothing. But pus is ocean, right? So you cannot obviously see anything. It's just like an ocean, right? So you cannot see anything. That is liquefactive necrosis. And this is dry gangrene. Obviously it is looking dry, so it is dry. This is looking wet, so this is wet. Easy to remember, right? Next, you have the caseous necrosis. It is kind of the combination. As I told you, it's more coagulative. So here, as you can see, coagulative, right? But here it's liquid type. So I told you maximum it's coagulative. And then seen in the lung, right? So this is the lung. Don't get scared. This is the lung, okay? Next, we have fatty necrosis, where there is chalky white deposits. See the chalky white deposits over here. And I told you earlier, right? This happens mainly in these guys, right? Trauma and acute pancreatitis. That is a fatty necrosis. And this is kind of obvious, right? You should tell. That is fibrinoid necrosis. You can see the blood vessels, right? Inflammation and everything. Vasculitis. So that is the fibrinoid necrosis. So let's end this necrosis chapter. It was a fun session. So let's just see one more time what all we have studied. Right? We have studied in necrosis, right? What causes it? Severe ischemia, remember. And what increases? Sodium and calcium. That is the intracellular calcium. And this fat guy, L-fat, right? This is going to call up P, so ATPase, protease, phospholipase and endonuclease. And finally the death happens. That is a mechanism. And we have studied the endonuclease activity. And in light microscope, how is it seen? In electron microscope, how is it seen? And the types of necrosis, mainly the coagulative necrosis, right? Liquefactive necrosis, caseous necrosis, fatty necrosis, and lastly, fibrinoid necrosis. So let's end this chapter on necrosis. In next session, we'll be studying about apoptosis. Thank you.